So today we're going to be finding the perimeter of irregular figures on the coordinate plane. In our last video, we were talking about perimeter of regular figures. So that meant squares, rectangles, and triangles. This time, our figure is going to look pretty wonky, and we want to make sure that we know how to find that perimeter around that area, that figure. So, first, you have to remember that perimeter is just the distance around a figure. Okay, we're not multiplying. All we're doing is just adding up all of the sides. So for irregular figures on the coordinate plane, we have to make sure that we identify all of the sides. So if you are given a figure and it doesn't have endpoint names, like you don't see any letters in the corners, then I highly suggest you write letters on all of those corners so that you can identify all of the sides of the shape without missing anything. We're first going to be finding the lengths of the horizontal and vertical sides because those are the easiest to count. And we're going to leave the diagonals till the end because we're going to try to draw those right triangles to use this modified version of that Pythagorean theorem distance formula. Once we find all of the lengths of our sides, we're going to add all of our sides together, not forgetting to always write units at the end, as that's what we have on the coordinate plane. So let's get started. As you can see, my shape is pretty wonky this time around. And I already labeled all of my vertices or all of my corners with different letters. So to keep yourself organized, it is really good for you to write down the segments you see in order. So if you're going to start here, move your way through the shape until you get back to the beginning, okay? Once you do that, then you start looking at your shape and asking yourself, well, which ones can I add straight through without having to use the distance formula? So it looks like segment AB, I can count. It is 1, 2, 3 spaces, 3 units. So I'm going to write that down. BC is a vertical piece, so I definitely can add that one as well. So that's 1, 2, 3. CD is 1, 2. It's a horizontal piece. DE, I can't count because it is a diagonal. So I'm going to skip this one and come back to it later. EF is vertical. So let's count it. 1, 2, 3, 4. So make sure that you're putting it in the right spot. This is EF. 4 units. FG is also a diagonal, so I can't just count it out. I'm going to skip it and come back to it later. GH, we're going to count the units. 1, 2, 3, 4, 5. So make sure to write it in the right spot. This is GH, 5. And HA is a beautiful vertical piece, so we're going to count it. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So as you can see, we are missing 2 lengths, length of DE and the length of FG. This is where we're going to build those right triangles to help us find the length of those sides. Okay. So I'm going to take my writing utensil and I'm going to create that right triangle. And I'm going to count how much my base is and how much my height is. So it looks like my base is 1, 2, 3, 4, and 1, 2, 3. So for segment DE, I'm going to take the square root of the base squared plus the height squared. So that's going to be 4 squared by 3 squared. I know 4 squared is 16, and 3 times itself is 9. 16 plus 9 is 25, and if I take the square root of 25, it will give me 5 units. So the length of DE is 5. I'm going to write that down in there. Okay, I'm going to do the same thing now, but for FG. I'm going to create that right triangle. And now I'm going to identify how long the base and how long the height is. So for the base, it's 1, 2, 3, 4. And for the height, it is 1, 2, 3, 4 as well. So I'm going to do the same thing. FG. I'm going to take the square root of the base squared plus the height squared. So this was 4 squared, because the base was 4, the height was 4. And now I'm going to simplify. 4 times 4 is 16. 4 times 4 is 16. 16 plus 16 is 32. And I don't know the square root of 32 off the top of my head, but I do have my trusty calculator that will help me out. So I'm going to click on second x squared to get my square root symbol. Type in 32. I get this decimal, and I have to round to the nearest tenth. That means I'm looking at this place value here. So we look at our neighbor. It's a 5. That means that we bump that 6 up 1 because it's 5. So that means that FG is going to be 5.7 units. Okay? Now that we finished, now we're going to add all of these up. Okay, so 3 plus 3 plus 2 plus 5 plus 4 plus 5.7 plus 5 plus 8. And then we're going to get the perimeter of this figure. Okay? So with your calculator, if you can pause your video, add it up, and let's see what we get. Okay. So I'm going to start from here. I know 8 plus 3 is 11, plus 3 is 14, plus 2 is 16, plus 5 is 21, plus 4 is 25, 30, 35.7. And of course, we label it in units. Okay. Always verify your answers. So one more time, I'm going to just check. 8 plus 3 is 11. 11 plus 3 is 14, 16, 21, 25, 30, 35.7. So that's good. Okay. Now for the second one. Okay. This also looks really wonky, and it's okay. So what we're going to do is we're going to do the same thing. Make sure that you are writing down all of the segment names so that you can keep track of all of them. As you can see, I have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So I know that I'll be on the right track here. Okay? So let's do it. JK is a diagonal. I can't work on it right now. I'm going to skip it. KL, diagonal. I'm going to skip it. But I can deal with LM. So I'm going to count 1, 2, 3. Write it down. MN is vertical. 1, 2. I can count that. NP, I cannot count right now. So I'm going to skip it. PQ, I can count, and it's only 2 units. Make sure to write them in the right spots. QR is vertical. It's 3 units. And RJ is 2 units. Okay? So now I have to find 3 segments. I have to find JK, KL, and NP. Okay? So let's try and figure those out and see what we get. Let's start with JK. So I'm going to first build my right triangle so I can find the base and the height. Okay? Alright, so it looks like my base is 3, and this is 1, 2, 3, and my height is 4. Okay, so for JK, it's going to be 3 squared plus 4 squared. 3 times 3 is 9. 4 times 4 is 16. 9 plus 16 is 25. And when you use your calculator, the square root of 25 should give you 5. Okay. Now I'm going to do KL. Same idea. Build your triangle. So it looks like my base is 2, my height is 2. So that's 2 squared plus 2 squared. 2 times 2 is 4. 2 times 2 is 4. 4 plus 4 is 8. And let's take a look and see what the square root of 8 is. That gives me 2.828. I'm looking at 8. Look at its neighbor. It stays the same. So we're at KL is 2.8. And now I have to tackle NP. So build your right triangle. Count the base. 1, 2, 3, 4. Count the height. 1, 2, 3. So I got 4 squared plus 3 squared. 4 times 4 is 16. 3 times 3 is 9. 16 plus 9 is 25. And the square root of 25 is 5. And we do not write the square root symbol. My apologies. So NP is 5. Okay, now that you have your 3 segments, make sure to include them in your list. And now you're going to add all of these together again. So this plus this one plus 3 plus 2 plus 5 plus 2 plus 3 and plus 2. Okay, if you have a calculator, pause the video, add them up, and we're going to write down what the perimeter of this figure is. Make sure that you always write this in complete sentence, the perimeter of the figure is. And let's do it. So I'm going to skip my decimal for now. So I'll go backwards. So 2 plus 3 is 5, plus 2 is 7, plus 5 is 12, plus 2 is 14, plus 3 is 17, plus 5 is 22, 24.8. I'm going to do it one more time just to be safe. So we go 2 plus 5 plus 2 is 7, plus 3 is 10, 12, 17, 19, 22, 24.8. There you go. There you have it. So I hope that now finding the perimeter of an irregular figure on the coordinate plane isn't too bad. Until next time, guys.